All right, hey, hello. Continuing the osdev series here. It's been a while, but I got more time, got motivation, got some things worked out. It is late at night here. I got a lamp going on. Hopefully the lighting's not too bad. I probably sound tired because I always sound tired, but for this little short section, I'm going to start a little slower, a little bit lighter things, and then I'll splice together the other parts that I get to as I go along with whatever I'm doing in this video. But I'm going to start off with some small things here. This make file, so clean, when I clean up my stuff and I remove the bin, which I also call it the start here whenever I do the default make or make OS, or in clean, this removes all the bin, but if there aren't any binary files to begin with, then it gives me an error, and I don't want to do that. I don't like that. We run if we remove all the binaries first, we don't have them here, and we do make or make OS, we get an error. I don't like that error. I think it's annoying. I want it to run through anyway. A very simple way of doing that is remove with the -F flag, which ignores error output. If we do man, this is for OpenBSD at least. There we go. If we look at the man page for it, we see -F, attempt to remove without prompting. If the file does not exist, do not display a diagnostic message or modify the exit status. So it overrides previous stuff. So we can just change the third RM to the RM-F at the bottom here. And that'll clear up any errors there, and it should work now hunky-dory. So, and there we go. We have all these. Okay, the second thing I wanted to do in the make file is change this from remove only the temporary. I want to remove really everything that isn't the final os.bin binary. The other ones kind of, I mean, if you want to look at them for testing your output and everything, that's fine. But I don't really need them to be in this folder, cluttering it up kind of. I really just need the OS binary in there because that's what I'm going to be using. So how do I remove everything but the temporary? What I can do is, instead of everything being a bin, just start it out here. If we want to remove everything that's a binary, we use the asterisk, the star. But if we want to not remove something, we can use in brackets, we can put exclamation for not, logical not, OS. So this will go and remove every binary exempting not OS. You might be able to put other stuff in here, but I'm just using it as one file for the pattern here. So what does that mean when we run make again? We have, boot set, calculator, editor, file, kernel, and OS. So if we run make again, we have just the os.bin that's left with us. So I like that. I'm going to add that to the git, which I changed everything. So I don't forget, I'm going to add that in there. So that's pretty good. That was just the first little, tiny thing I wanted to warm up with here. Okay, the other slightly larger thing that I think I ended the last video with was the editor, right? I wanted to be able to run multiple lines of input one after each other without like restarting the whole thing or whatnot. So putting a return command. So, and I'll have to do this before we jump and execute the hex code. So I'll put it under here, do this, find a way to get to this point for reset. Okay. So the x86 code for returning, for the return command, like down here, RET, this return command, that hex code is C3 in hex for a near return or something else for a far return. I think I have it in a, okay, so x86 instruction set reference, this is one page that has it, return. So C3, not C3PO, but just C3 return is a near return. CB is a far return. I don't know what the difference is though. Current code segment for the near return. If it's a far jump, then we can do a far return to go back. But this is just a near return, and we're not going to pop anything from the stack and be fancy with it. We're just going to do regular C3 for near return to the current code segment. So, and just to show that that works, so it makes a little bit more sense, because that might not make a whole bunch of sense by itself. I'm also going to be running things in QEMU, probably primarily because QEMU runs faster for me. With these options, just -fda for a floppy, give it the os.bin. This will put a warning in here. I might change my my thing eventually to run in the make file so that I don't get the warning, but right now I get a warning from that. But anyway, editor 4 spaces, eventually I'll fix that. So C3 is a near return. So this screen is just going to reset like right here. If I do a C3, capital C3, and then do the $sign to run, I think. So it just re-goes back, and you can, well, this isn't going to work because I don't have backspace and everything. But the question mark goes back. But yeah, C3, you execute that, it just goes back. Normally it goes back. So that time kind of broke. So there might be some bugs with it. So let's go back to the editor. Let's put that in here. So to put C3 in there before we go, DI should be pointing to the current location at hex code. So I think we can just increment DI and put the C3 at that point. So let's see if that works. So into DI, let's move bytes if we can. I don't know if I can do this, but we'll see. Move into the data at DI. We'll move the byte C3H. I have to put a 0 in front, otherwise it doesn't recognize it as hex. Okay, so let's see if this works. Let's do 0 C3H. But we want this to be at the next point, so we might increment first, or we can do +1 maybe, and that'll work. So let's see if this works. We're moving 1 byte, C3 into DI +1. See if we need that or not, I don't know. All right, we'll do make. Operand size not specified, so we do need the byte mnemonic there. That's what I thought. All right. So let's run make again, and that time it worked. It'll return immediately if we put a C3 in. When I say return immediately, if we print anything to the screen, since we're putting in a return and it returns immediately after, it's kind of just going to reset the screen, so it really doesn't matter what we put in here, I think. So if I put in like F4, and then I just try to run this with question mark, it should just reload. And it didn't because F4 is halt. Okay, so that's good. Since we increment DI automatically right here, I didn't need to put the +1. So let's see if this works instead, or works a little better. But I'm going to put in the code like I did at the end of the last video, which is to clear the screen again, set the video mode, print a T, and then halt. So I'm curious if it's going to halt or if it's going to return because of the C3 that I'm inserting. We're going to find out. So let's see what this does. It prints the T. Okay, and I think it halted. No, it didn't halt. Run it again. Prints the T. Run it again. Well, now it halted. All right, so let's put that in without the halt command, which, let's see. Let's go into our test file here. Instead of halting, let's get rid of that. Do not do that. This just removes the F4 on the end. Okay, so let's just enter the same thing again with F4 not on the end and see if it returns instead of halting. Okay, so without the F4 to halt, what happens? Prints the T. Figure it would have executed the C3 and returned. It did not. So that's the, oh. So it does return, but it doesn't clear the screen when it returns. It still leaves the T from printing. So I'm just going to test on both box and quick emulator. But if we insert a C3, it should return back. Just to make sure that does work, I am resetting the text screen here. I'm not going to do this for a second. Let's not reset the text screen every time. Okay, so let's set this to not be blue. Let's change this to be green, right? Let's just change this to be green. That way we can really tell. The screen stays green, we'll know that we actually executed this and then returned. All right, so this just changes this color here. So it was a 1, now it's going to be a 2. Okay. So since I am running the editor right now, but since I didn't clear the screen, it doesn't clear the screen. But we can put in our code here. All right, so this should print a T in the top left maybe, or it'll print a T at the cursor. It'll print a T in the top left because it'll reset the text mode. There we go. There is a T up there. It's very hard to see, but there is a T up there. And I know we're still in. We did return. We can still enter text here, like C3, and then return. We can also just do a normal return with a $, and then I think still type stuff in. Yep. Let me type this stuff in again to change the screen back to blue. All right. And there we go. Anyway, appending C3 to the end of the text code, everything works. It looks like, which is great. Doesn't work fully, or at least not correctly all the time in QEMU, but it doesn't box. So as long as one works, I'm okay with that. I'm all right with that. We'll just append C3 right here. There we go. All right, near return x86 instruction. I may also look up if there's like a sleep function to sleep for like a second or two. I don't think there is. I might have to put like a busy loop or something. I might put in something to sleep for like a second or two just so you can see, hey, this did actually run before it returns. Because right now it returns immediately from executing this C3 line, and it's hard to tell. That's why I had to go through that whole tirade there, changing the screen color. So these other things are basically, I think, like minor. A lot of these are just minor changes that I thought might work better. So right here, where I have move AL into the memory area at DI, and then I have increment DI, well, there's an instruction called store string byte, which does just these two things exactly, so I don't really need to do this. I can just put stosb, store string byte. It does the equivalent of moving AL into the memory pointed at by DI, and then incrementing DI. It does both of those. Like load string byte, loads SI. Store string byte stores into DI. All right, that's just the equivalent. Just looks a little bit cleaner. Okay, so another, I guess, a little bit more involved thing I want to do is when we're in our editor here, we don't really know what's going on. There's not really any info that's given to us, which is not great. I didn't take out the screen clear, did I? I didn't put it back in. No, I did not. All right, let's put that back in. All right, okay. So when we run the editor here, we don't have any feedback. We don't really have anything much at all. I want to put in a little, not unlike the bottom line in Vim or the mode line, whatever it's called in Emacs. I kind of want to put a little line down here that at the very least, I guess it'd be like Nano more so, that just has the controls that we got so far, which is running the $ to return or execute our code, or question mark, which goes back to the kernel. I just want to put those two things in the bottom. And then if I develop other options here in the hex monitor mode of our editor to like save or load a file or something else, I can put those at the bottom as well. I want to do that right quick because I think that would be a good UX improvement. It'd look a bit better. Okay, so in our editor here at the bottom, let me put another string here. I don't think it'll be a variable. It'll be after here. I'll call it controls string. Kind of awkward. We can change it later. That's fine. Control string. And it's going to be $ equals run code question mark equals return to kernel. So I want to put this in the bottom of the screen. So what is a good way to do that? Well, there's BIOS interrupts for moving the mouse cursor or moving the screen cursor. Like, I have this block with the cursor. When I start up the editor, I have the flat line. That signifies where your current text is going to go. So you can move that cursor with BIOS interrupts, or I can sort of write this code or write these characters directly to video memory. And I think I want to go with that because I think going forward, I want to try to rely less on the BIOS interrupts so that it's easier to move into protected mode or long mode or whatever in the future as we go along. And it's a little more involved and it teaches more about how things work than using black box APIs that the BIOS interrupts are pretty much. So they're not guaranteed to work the same on all systems. Video memory isn't either, but I think video memory is more agnostic and interrelated between vendors than BIOS stuff. BIOS doesn't really have a set standard. I'm going to write to video memory, attempt to write to video memory, these characters, and see what happens. So how do I go about doing that? Well, the text mode, we're in color text mode here, 80 by 25 characters, but it's color. It's not monochrome. The color text mode video memory area, which I'll put up here, is A8000, but I'll call it vidmem. I want to make these constants. There we go. That's all I had to do. Okay. And input, just make it all caps. Thank you, Vim. All right. B800 or 0B800H, right? This doesn't need to be in quotes because it's a hex number, but so B800 is the location in video memory where your screen is in VGA text mode, well, VGA colored text mode. If it was monochrome text mode, it would be B000, and if it was full-on graphics mode with colors, it would be A000, but color text mode that we're in this, for the moment, is a B800. So if we write bytes to this memory location, we'll have text appear on the screen if we write valid ASCII hex bytes. So the ASCII code for A is like 65 or whatever. If we write a 65 here and we give it, well, it's 2 bytes. It's 1 byte for the character and 1 byte for the colors that you want the character to be, background and foreground. If we write the color and then the character, we can write, whatever we want to the screen. So we look here, osdev, awesome resource, print to screen. So, writing B8000, or we're in 16-bit mode, B800, similar. It works the same. We write to here the byte for the ASCII character we want to print on the screen, and then we write the color for that character. Color table right here. Sorry, the first nibble is the background, second nibble is the foreground. If we put in an H or an A or whatever, an A would be 65. So if we put, decimal 65, and then as the next byte right after, we could put in a 0 for black background and a 1 for blue foreground, which would be a blue A. So I don't know if we'll want to do that. We'll probably keep our text color we got going on right now, which I think is light gray, or maybe it's white, which is 15, or F. We can try white, and we can try gray and see what it looks like. So we'll try 1F, and then we'll try 1.7. We'll see what looks okay. But I want to try to write this into the screen, write our bytes into the screen at the bottom. So how do we write them at the bottom? Well, since each character here in text mode takes up 2 bytes, we can go by character cells in here. So what I mean by that is, since we have 1 byte for a character and 1 byte for the color, each character takes up 2 bytes. We're in 80 by 25 text mode, which means 80 character width and 25 rows. So, and then 0 to 25, zero-based indexing would be 0 to 79 and 0 to 24 to reference all those. So if we want to write in the bottom row of the screen, it would be row 24 in our zero-based indexing here. So we would need the number of characters in a row, which is 80, times the width of the characters, which is 2. That'd be 160 bytes per row into row 24. So we'd have to skip like 23 rows or add 23 rows to get to the 24th row. So I think we can do something like 80 times 2 times 23 to get to the 24th row. If my math is correct at this time of night, I don't know. If it's not, then we'll fix it, but we're going to try to write into this area here. So where do I want to write that? I do want to write that at the bottom. So we'll do it like right after here. Keybinds at bottom of screen. Let me try something. Hopefully SI and DI are set up, or ES and DS are set up in the same area. I think they are. Let's go to where we run and load our programs here. Found program, restart search. So when we do the far jump, so ES and DS are equal, so our comparison should be okay for ESDI and DSSI. That's all I wanted to check. So if we move SI to point towards our control string, okay, and we did null terminate that, yes, okay. So SIO points towards control string, so we want to move into DI. We can move video memory, and then we can just do addition here, and we'll add 80 times 2 times 23, or I can do that in a calculator and see what that equals. Where's B? B, 800, what is that in decimal? 47104. Okay, so if we do 80 times 2 times 23 plus 47104, 50,784, or C660. Okay. So let's move that into DI. C660, repping with the 0 for hex. Okay, we don't need this, so I don't think this will work. We'll see what happens though. I'll have to change it, but ideally that's what we would want. We want to write the bytes into that location. So I think it's move string byte is the command to move from SI to DI, but I'm not exactly sure. So move S transfers the string element. I'm at the flat assembler docs. Okay, move S transfers string element pointed to by SI to location at DI. So it moves the data at SI into DI. Let's try that. That moves SI into DI. Let's try to move that. We want to repeat. Can I use repeat on these? Repeat is only for scan and compare, so no I can't. I'll have to do a loop. Okay. But I'll need the length of the thing. So 35 characters. Move CX35. Okay. Let's do our dot loop here. Let's do move. So this should, that's what this should do. It should move SI into DI and increment both. Jump CX0. I don't know if I've used this command yet, this mnemonic yet inside the osdev series. I did when I made a boot sector Pong, if you want to look at that video. But anyway, if CX is 0, there's a special jump command for it, JCXZ, which is jump if CX is 0. So instead of comparing CX to 0 and then jumping, I can just do this, jump CX0. Back to loop. And then we'll move this again, which this should automatically decrement. We can check by setting the direction flag with the std command, which is always nice. That should increment instead of decrement. If we did CLD to clear direction flag, they would SI and DI would decrement, but since it's std, this should be set direction flag. Set direction flag. Increment operands. Okay. I'm hoping this will work, and it's relatively simple. Probably won't at all. Probably fail to a symbol. Undefined symbol, control string. Okay. Controls string. Let's just make it control string. Let's call it, you know what? Let's call it keybinds. That's a lot simpler. Let's just call it keybinds. A lot simpler. Okay. Keybinds. There we go. So that actually assembled, which scares me. It's like compiling stuff on the first try, second try, whatever. And nothing shows up at the bottom. We're putting the characters in, but we're not putting what color the characters should be. Yeah, so we're moving the characters, but we're not moving the colors for the characters. What color do I want stuff to be in hex? Probably, what did I want it to be, like white on blue, so a 1F. I'll need a 1F after every character. A little bit annoying, but that's okay. 1F after every character, so I'll need... Oh, this is really going to be annoying. $1FX. And then the next one equals 1FH. Okay, so I'm gonna be doing this. What I could do is do a move, and then another one of the. You know what? I'm just gonna type this out. I'll be back in a second. Okay, so I put the all the keybinds here. Every character with the 1FH for the blue background with the 1 and the white foreground with the F. Hopefully it works out. That also doubled the size, right? Doubled the size of the characters. So instead of 35, we will do 70. 70, okay. Let's see. Should be writing things at the bottom. Should be writing characters there, in fact. I'm curious as to why that is not happening, but... Okay, well, I will be back when I figure that out. Okay, so, as always, when I try something for the first time, I mess up spectacularly and nothing works, but after messing with this for a little bit. So I changed, I wrote out all this at the bottom. The colors, this stuff works somewhat, kind of, not for the most part right now, but this works fine. But what I needed was to set the extra segment. So this is B800, but really this is actually B800 offset, into that segment 0. So the B800 is the segment. I don't think you can do 0 and then B800. It doesn't really work, but anyway. If I set AX to vidmem, because I can't move directly into ES an immediate value, I move our video memory, our B800 into ES, so that this points to B800 0. Then I move the offset that I want into our video memory from the segment at B800. The offset I want is the last row, 80 characters per row, 2 bytes per character, 24 rows to get to the last one. So we move that into DI, that's F00 in hex. This is like 3840 or something, 80 times 2 times 24. That value in hex is F00, move that into DI. So ESDI points to B800 and then offset 80 by 2 by 24. Okay, and then SI can point to our keybinds down here. CX, I think I counted 67 of these bytes. It's probably not correct, but close enough. Set direction flag, move string byte. Also, this jump cx0, we want to jump if cx is 0. It's not 0 till we want to end the loop. I made another little label after. So when we deplete all the 67 bytes, then it'll be 0, then we'll jump, not premature, which it was just firing off immediately, which is not great. I swear that never happens. And we jump to the loop if it's not 0. So this could probably be better, but that's what I'm doing. But anyway, let me show you what that looks like. When we run it in the editor, it does print at the bottom, but we get this crazy garbage here for some reason, and we can't enter in text. C3, $, question mark. See, it's ignoring scan codes. I don't know why it's doing this, but anyway, I just wanted to show you. We did get the text to print correctly. I probably still have some segment issues I have to sort out to get this not looking like this, but I don't know. For whatever reason, this is messed up. But anyway, we got this. See, we can write text directly to the screen by writing to the video memory, which is what I wanted to show. I'm going to be moving my development towards that, method in the future. So anyway, this prints here. I'll probably put a space or some spaces in front, and I'll make this, I think, gray is what our stuff usually is. I didn't need to make it again, but this text is gray, not directly white, so I'm going to make it gray by setting all these Fs. One is blue, but F is white. So I'm going to set all these Fs to 7 for gray. And then I'll try to figure out why it's going all crazy and haywire with the weird clown colors and everything messing up. So when I figure that out, which will definitely be at least tomorrow because I need to go to bed. When I figure that out, I'll splice that in the video and you'll just be, directly there. So I'll see you then. All right, guys, so I lied. I'm actually still here because I can't let things go to rest, and including myself, until I figure them out. I still don't know why it was doing the weird stuff. I did realize I had set direction flag. I'm reading the docs wrong. That's how I know it's late. But anyway, clear direction flag, CLD, increments, string mnemonic operands. Set direction flag, STD, would decrement, but clear direction flag will increment. So clear direction flag is needed. I'm still using the same things down here. I did change it to 7 for gray instead of F for white. But it was 67. I halved it to about 33. I don't think I need the null on the end anymore, actually. So let me get rid of that, see if it messes up or not. But anyway, I cut that in half to 33 because I'm doing move string word instead. And also, again, I read the document, the flat assembler documentation wrong. The repeat prefix can work for any of the string things. It was just repeat, not 0 or not equal or whatever. The more specified repeat prefix only worked for scan and compare, but the repeat by itself definitely works for any, or at least most of the string operations, including move string byte, string word, string double word. So if we move a word at a time, which makes sense because each character writing to video memory will be 1 byte for the ASCII character, 1 byte for the color, so 2 bytes, so 1 word. So it makes sense to move at a word level. We can just do this instead of the loop and labels and nonsense. Just do this, and repeat will automatically decrement CX and move on when it's 0. So that makes it a lot clearer, and I don't know exactly why. But this fixes our data issue. So something with the string operation here, incrementing them and decrementing CX, I guess worked correctly, where my previous implementation here did not work correctly. But sorry, I'll show what it looks like here. It does run, and it runs fine. So I run our editor, see it prints the stuff at the bottom. It's now the gray text, and we get our blinking cursor at the top. We can run, C3 and run it back. We can go back. So, I mean, that works. I don't know why, but it works. But anyway, that's all you need to do to write into video memory. You set your extra segment equal to B800 if you're in text mode, color text mode. If you're in graphics mode, then this would be A000. If you're in monochrome text mode, this will be B000. But B800 text mode for colors. And, I move the offset we want to write into. I move that into DI, word value, 80 by 2 by 24 for the last row. I still might put some spaces in front to clear it out. But anyway, we get the number of characters we want to repeat. We write those to DI from SI with move string word, clearing the direction flag so we increment. And we restore the segment after, that we don't, ES was pointing to video memory. I want to restore it afterwards back to wherever our program is running, which is set from the kernel to location 8000. So I'm just resetting that. And then we can run our stuff as normal, taking the input. And yeah, so we're good to go. I got that done. I'll move on to some other smaller or larger things when I get back and splice it in the video. So yeah, I'll see you then. Okay, I got a couple minutes here tonight, not very long, but I think I can do a couple more smaller things, hopefully. I want to actually set up the stack. I think the only place I'm maybe setting up the stack segment is in the kernel, I'm hoping, but I'll just change other locations where they show up. So let's just look right quick in the kernel here. So are we moving anything? Okay, so we're moving the stack segment here, so I don't want to mess with the stack segment here. I just want to I think I'll set it up in the boot sector. But there's nowhere else that is, in this file at least. Okay, I think I can use grep, right? So I go here, so that way I have access to, let's go to source. I have all these files. So if I use grep, recursive search for move SS. Okay, that does not work because I didn't set a location to use it from. SS and then file starting here. Okay, so boot sector has it, calculator has it, editor has it. Well, calculator I'm not really using right now, but I guess I'll change it in there just in case. I think -O would open in vertical splits, right? So let's see if we go to assembly, calculator, and then also into the editor. It does open both. Okay, so calculator, where am I setting SS? Down here, let's get rid of that. Save it. And then the editor. Here, we don't need to worry about it. Okay. I'm hoping we don't need to worry about it. We don't until later. Doesn't really matter. So, boot sector. So let's set up the stack in here. Right before I jump, we'll put it here. Do setup stack. Okay. So where do I want to put the stack? Well, the stack grows downwards, not upwards, in case you didn't know. But I think a lot of, well, maybe not a lot. I don't really know. I think some conventions put the stack at like the end of usable memory and then give it, enough space away from everything, away from where you might load programs or be running anything, away from the kernel memory space. So that doesn't interfere with anything. So that's kind of what I'm going to do. I'm going to move the stack pointer to, I don't know if I can directly move immediate value into there, but we'll try it. But I kind of want to move it into like the end of usable memory. So FFFF in 16-bit real mode, we'll just move it there. So I'll try that. And then the stack segment, I will move to like 9,000. Not over 9,000, but just 9,000. Then we'll set up the stack segment there. So we'll do stack pointer, stack segment. So that just gives a bunch of, I don't know if I'll ever, well, I might. If I'm passing like giant arrays or anything later on, or giant screen data or something, buffers, then I'll need a good bit of space. So 1000 hex, I think, is 4096. So 1000 hex is 4 kilobytes or a normal page. So this gives, 6 of those. So maybe 24 kilobytes, but anyway, for the stack, it should be all right. At least for what we're doing now. I'm only going to push or pop like several different arguments, not like hundreds, not any big arrays or anything just yet. So this should work all right. We'll set up the stack here, and we're good to go for pushing and popping in the future. But it'll grow downward from FFFF down to 9,000. And if somehow this interferes with the reset vector location or anything, which should be at FFFF0, if it does interfere, I'll just move this a byte or two down to like E or D or something. So, but I think that's okay for a basic stack setup right now until we need to change it later. So down here where I'm getting the file size, I don't need to do all this to get the file size. There is an imul instruction, which is signed integer multiply. Well, maybe not integer multiply. I guess it is, but it's signed multiply, which can take multiple operands, and also up to 3 operands, not just 2. So imul, you put into your destination, you can put your source or something, and you can also put a multiplier. which this might be not exactly what it's called, but anyway, you can take this operand 2, multiply it by operand 3, and that'll be put into the first operand for sign multiplication. So I'm going to do that. Hopefully it'll still work to get the file size. So instead of comparing to 0, jumping equal, adding 512 for each file size byte we have, I should be able to put into, this is into CX, right? Yeah, put into CX file size times 512. So we'll say, how large is file size? Compare byte. So let's put the bytes at file size multiplied by 512. We'll put that into CX. So I'm hoping this will work. We'll see if it does or not. We'll just do all that for now. We'll make it operand sizes do not match. Okay, we have to do a word value for CX, unfortunately. Let's just try word file size and see what happens. I want to do it in CX. Okay. Okay, so that does compile. Okay, so let's see what happens. I'll try it in box and QEMU. See if it even works. What files do we have? So the only thing we can really print out as ASCII bytes right now is file table, which is one space. Okay, that still prints out fine, it looks like. I think we're good to go. Okay. That wasn't too bad. QEMU, let's try it QEMU just to make sure. File table space. Okay, so it works the same. I do want to change that where I'm printing it out. I want to put a new line here at the end. Move this back because I don't like that being in the middle there. So let's go ahead and try to make that happen. Whenever it's 0, whenever it's done printing. At least I'm glad this stuff works, right? That's always good. So after all this is done, let's, I want to make a print character function eventually too, but I'm not going to do that at the moment. I'm going to do my old standard, move 0e in the character I want to print. So 0e, and then I'll do 0a and 0d for AH to get the new line working. So in 10, and then move AH, 0DH, and 10. So after all printed, go back to prompt. So let's see what that does, if it even works. That did. QEMU, file table, space. Okay, it doesn't move the cursor though. It does print the new line, which is nice. But it just moves down. It doesn't go to the start, which is weird because I thought 0A, 0D was carriage return and line feed. 0E should be an AH, yes. 0A and AL. Oh, move AH. This needs to be AL. Duh. Thank you for not noticing that, brain. That's always good. Okay, there we go. Proper new line handling. Okay, so that's good. We fixed that up too. Can mark that off. Mark that off. Okay, so another smallish thing. Maybe the last thing I'm going to do tonight. I want to make a shutdown command. There's not really, for actual OS dev, it's a bit more complicated. I think you have to talk to and find like ACPI structures or power management structures and query your stuff for them, and that can be a little complicated, so I'm not going to get into that. But there is a basic shutdown command I can run for either Box or QEMU, I think, but I have the QEMU one written down, so I'm going to use that. So I'm going to make a new command wherever I have all these other ones. This one, since the editor, we'll put it above the editor. Command, I'm going to call it shutdown. DB, it's going to be shutdown. I'm hoping it does what I want it to do, which is close the window in the program. I don't know if it will, but hopefully this will close QEMU. Let's just copy these. I always forget keybinds when I try to talk and end up saying nothing. Okay, P, there we go. All right, so let's check. Command shutdown. P jump equal, we'll do shutdown, right? Yeah. Let's make a thing for shutdown down here somewhere at the bottom. I don't know. It doesn't really matter. Before in program, I guess we'll put it here. Shutdown. And we'll call it shutdown, right? That's what I called it. So what this will do is we're going to use the out command, which writes data to an output port. You can imagine just, ephemeral ports, but we're writing data to a port that QEMU has assigned that the developers made for an easy shutdown, I guess. Basically want to write out, or outward if you do C code, 604. So we want to write the hex code 2000 to port 604. So we need to do something like, you can write an immediate value if you do out for out byte, only for 8-bit values, right? For 1-byte values, you can do out with an immediate value. So if this was 200, this would work, but this is 2000, so that's not really going to work. We have to use a register. So I'm going to move into AX 2000 or 2000 hex. And then I'm going to out to wherever we move 604. Let's move it to like DX, say. Move DX 604H. And then we'll do out DXAX. So I'm hoping this works. I don't think this works in Box. Box has a different port and different number, but this hopefully works for QEMU if I wrote it down right. We will see. Invalid value, that's always good. 1536. Oh, so now this goes over 3 sectors. Okay, interesting. So 2048, let's do and try it. 48. Wow, we're at 4 sectors now. That means I have to affect the change the file table too. So let's do that. I think it's in assembly, yeah. File table. The kernel's at 4 sectors in length, dang. Growing. The boy's growing, so this has to change to 6. This needs to change to 7, change to 8. I think that's all I have to do. Print directory command, that doesn't work anymore, of course, because why would it? So we moved everything. Change the boot sector. I'll have a better way of doing this eventually for saving and loading files. Right now I haven't made any save or load programs inside the OS. That's one of the next things I want to do, actually. In one of the next videos on this, I'll try to make a save and load disk program and make them actually work, for the editor at least. So we can edit files within the editor. That would be nice. Let's go back and change the boot sector. So the file table will be at sector 6 at the moment. Read it. Let me change this label too. I don't like this label. Let's change this to load file table. Maybe I'll do full snake case. Why not? So load file table. Jump carry load again. This too is loading the kernel. So let's just call this load kernel. That makes more sense. Surprised it's taking me this long to rename these. Well, I'm not surprised actually. But okay, file table sector 6. Does it work now? Hopefully. There we go. Now we can load things. Reg, that works. Okay, so let's try shutdown. Hey, look at that. You just write to the output port and QEMU shuts down. Beautiful. I like that. That works like a charm. I'm real happy about that. So now if I'm in QEMU, I can do the shutdown command. It'll work. I want to make a command that lists all the other commands. And that's another thing I want to do. I think I have that written down, but I'll write that down if I don't. Yeah, I have that written down. But okay, we did a shutdown command. I'll mark that off. I know I don't sound enthused, rarely if ever, but I am actually pretty happy at something simple like that. 1, just working right off the bat, and 2, that I don't have to. I mean, it's easy. I can do control. This is CWM, right? So Control Alt X closes the window, but I just like having a utility, even though it's only emulator specific. I like having a little thing that just works. So we have a shutdown and a reboot now, so we're almost to full OS, right? Almost. I can either do a print character function, and then a print string function, which works a little bit differently. I want to like write to video memory and move the cursor with either a BIOS interrupt or writing directly to the hardware cursor. I think in the CRT microcontroller registers or something I was reading up on, which uses the out and in instructions to write to the ports. I don't think it uses in, it uses out, but you can use in to get data. Anyway, we can change the print character, print string functions. I can change the clear screen, actually implement clear screen function by clearing, by setting like all the data, writing to video memory and setting just write spaces pretty much, or null bytes to clear the screen, and then move the hardware cursor. Again, with either BIOS interrupt or writing to hardware registers to move the cursor without commands. We can work on putting save and load files in. So load file from the disk, save file to the disk, have a couple programs / files for that, and call them within the editor to load and save source code, and then also save like new text files to disk, say, or update current files. So I have ideas for those, and I think I'll try to work towards, you know, those things or other things as my mind comes up with them. My ADD allows. I think I have ADD sometimes. I don't know. Could be too much or lack of caffeine, right? But I'm going to go to bed. I'm rambling. I'm probably going to cut all this out of the video anyway. So yeah, I'll see ya.